And we are off again! Happy Sunday, everybody! Welcome to The First Layer, the show that explores the world of 3D printing. Today is Sunday's TFL Ask for Help. Now, you're going to see a little bit of a dynamic change here today because we are sans Richard. Now, unfortunately, he's been a little under the weather this week, so he asked me just to solo this one. Now, in the caveats of that, it has been a long time since I've done a stream here, so at least streaming from my side. So let me know in the chat if all the audio is coming through good, if the video is coming through good. I just kind of winged it together this morning there. But yeah, let's see who we got here today. Hopefully this will actually show properly for us here. I see Greg's Vintage Workshop, Peter Reynolds, and Radmaster, Gary T, Accord XTC. It's just going to dynamically update on it. So thank you everybody for coming. Really appreciate it. Now, true caveat here, truth be told, I don't have access to the emails. So if you did send in an email, all I'm going to ask is either let us know in the chat what the question is, and I'll do my best to improv it, if you will, or we will go in the following days and send you a personal email and address your concerns privately. That way you're not waiting another week for your questions. How is everybody this week? You know, Gary T, new haircut? No, I finally found the right hair gel that can hold this hair up. Now, normally when I'm talking with Richard, you'll see me wearing some, let's call them gaudy headphones. I've got some pretty nice headphones here. When you wear headphones with something like that, the first thing it does is just presses down the hair, so you end up with a really wild hairdo by the end of the day. So yeah, it has been it's been an exciting one, obviously, here. On my side of things, well, for those of you who watched my video on Prusa Slicer and were very critical of my Benchy, I don't blame you. I've been doing a lot of digging into my CR-10, and what I actually found was I had a combination of fried I/O pins on some of my main processor, and I actually had a bad extruder stepper. So I've been going and doing a few upgrades this week. I upgraded the board from a SKR 1.3 to a 1.4 turbo, and I just got yesterday, I haven't had a chance to install it yet, the version 2 of the S42B closed loop stepper from Big Tree Tech. Now this is a board that attempts to go and correct any offsets when the extruder moves, basically, or whatever motor it's hooked up to. It's a neat little board, actually, and I finally got it working right, and I have it on my CR-10. It's nice. I mean, the extrusions seem a lot smoother. To give you a comparison, I just spun this cube off on a 0.8 nozzle just before we went live here, so that was a 28-minute print. And there is some tuning, as you can see, to go in. The temperature is a little warm on the X there, so the corners are a bit rounded. The Y, oops, sorry, there we go. The Y needs a little bit of love there. But that top layer is looking pretty nice. Sorry, everything's backwards on my camera, so I'm getting used to this again here. Yeah, so it was, it's a nice little addition in there. So, you know, obviously we've all had some struggles this week, and I was trying to get this little scene set up before the show. The only one I managed to get in mind is, you know, the kind of week I had, which was... Okay, that's probably my favorite video I've made this week. I won't lie to you guys. It's using an app on Android called Reface there, which allows you to drop faces on videos. I thought it was a good laugh. But this week's theme, if you will, for Sunday is Spaghetti Sunday. So I want to know from you guys, I want to see what your spaghetti nightmares are this week. I'm going to see if I can pull up the right image here, but I don't think, no, it's not going to work properly. I had a heck of a spaghetti bomb because I left a print overnight, so I think there was more spaghetti than there was actual print on that one. It was probably like 100 grams of filament, so not fun. No, I don't use the spaghetti filters and all that. But anyways, back to you guys here. What do we got on the questions this week here? Dominic, yeah, you know, okay, so let me tell you how we set up YouTube here. So whenever you go to create a live stream, you have to create a scheduled event if you want it to drop at a certain time. Now, I ended up putting the dropout at about 11:40 here, which was 20 minutes ago. So if you hadn't received a notification after that, I'm sorry, it's YouTube. Now, for those of you who are confused, because it might be a different time for you today, where we live, we still participate in daylight savings time, and so the clocks jumped ahead an hour this morning. So right now, it's normally what would be 1 o'clock here. The whole world is changing on this, but we're a little behind on the times. So yeah, sorry if it is an hour later for you guys today there. Amin Baines, hi everyone. Hey Amin. Pierre, question. Bilinear bed leveling in Marlin. Mine starts at the front right. Is there a start like front left as it is X0 and Y0? That's a great question. I haven't looked too deeply into that, but I do know that depending on if you use an even number or an odd number, it's going to determine where it ends. And I believe it usually starts in the front right, even regardless of algorithm. I should have looked at mine this morning when I was doing that because I have a 4x4 grid, if I recall. I will take a look into that, Pierre, and hopefully I'll be able to give you some information for next week. LB Sharp, has anyone ever get their Creality 3D viewer software to work? I've never been able to log in yet. I personally never used that program. Richard did the review for the 3D viewer, if you will, and we used the Android app for that. So, for those who don't know, the 3D viewer is this cute little camera, basically, from Creality. And sorry, I have to bring it up because it's been a while since I've looked at it. It's a combination camera and print server, and, you know, at $50, it's a neat little device. Honestly, personal opinion, I don't like daisy-chaining devices to my printers when it comes to streaming G-code, and that's why I just opted not to go that route with it. It's why I also don't generally run Octoprint or anything. I just like to put the SD card right in the machine and let her run, because it's meant to be an autonomous machine. Now, if you do want to daisy-chain all your machines, options like the 3D viewer are great. I haven't tried that new Wi-Fi printer module they brought out either, but anytime you have OEM stuff, you know, I'm hesitant on it. I'll explain why. I've been using Android phones since the first Android, I think it was the HTC G1 in the US. It was called the HTC Dream in Canada. It ran Android 1.5. I've been running Android since then, and one thing you'll realize with companies is they tend not to update their software after a certain period. And usually that magical period is about 18 months, give or take, a year and a half in. You know, if there's a longer warranty period, they tend to support it longer. But with these sort of products, you know, I like to buy hardware that's open source, that you can go and build your own software in the future, so that if they do decide to stop supporting it, then you're going to go and still have usage of the device, if you will. You won't have an insecure device on your network because of the outdating. And yeah, I prefer open source for that reason. So, you know, I did avoid that viewer. Sorry if that's kind of a non-answer, but my only response to that is you can attempt to contact Creality. I think Naomi Wu still has some links within Creality, so you can bug her on Twitter and maybe get it into the right ears, but yeah, unfortunately, I have no experience with that software. Sorry about that. Saying you want to check on the printer when not home and shut down if need to. Yeah, I can totally understand that. The problem is everyone's trying to reinvent the wheel, right? At the end of the day, if you really need that sort of protection, what I generally use is I use Wisecams, because they're great for security, for rolling back. They just work. They got night vision built in. And then if I really need to do a hard cutoff of my printer, you can go and get a Wi-Fi relay. I've got a couple ones behind me here that are $20 a pop. And yes, it'll cut the power. Yes, potentially you'll have some heat creep, but you only want to be using that in a really bad situation, if you will. Now, if you do want to have the more advanced features to have it auto cool down and stop the print, then yes, then we need to look into these serial interfacing devices. And frankly, there's not a lot of competition on the market for that, so maybe we'll see some more smarter devices come in the future. I know for the Big Tree Tech boards, you can attach these little ESP01 boards and program it and act as a smart Wi-Fi module that links right into it. That might be the best route. Anyways, yeah, so as I said earlier, I don't have access to the emails, and I'm sorry for that, so I'm going to rely on you guys to ask all the questions in the chat here this week, and I will keep an eye on it. Otherwise, we'll talk about different project ideas and what we're working on. So, as I've said earlier here, I had a lot of problems with my CR-10 this week, so I have been, you know, tweaking the frame, I have been changing out the motherboard, checking all the wiring. I even stole my father-in-law's thermal camera just to go and check the beds and all that. And I've been doing a lot of neat experimenting. And one of the things I wanted to share with you guys, and this is something I don't think I could really do a long video on, so I'll kind of share it with you guys, is bed insulation. So early on, when a lot of the 3D printers came out, there was no insulation under the bed. Now, as a result, heat radiates in every direction. It radiates down, it radiates up, and you want it to go up, right? Because you want your bed surface to be warm. Now, we've said it many times in the past that the thermistor for the bed is actually located on the bottom side. And so even though the thermistor is reading 60 degrees, that doesn't mean your bed, where the filament comes in touch with it, is 60 degrees as well. And that's where, we can play with thermal cameras, but infrared light can be variable. You kind of have to do a guess and check, or pull your probe out and hold it on the top of the bed, for instance, see what the deviation is. So what we want to do is we want to maximize the insulation on the bottom side of the bed so that the heat, as much of it that's being generated, radiates upwards rather than downwards. And a great example of where you can see heat radiation issues is look at a CR-10S 4 or 5, notably the 5, because the 5 actually only has a heating element that fits in a 300 mil by 300 mil area. So you've actually got 200 mil on the top side, 200 mil on the bottom side, which is basically 100 mil on every axis, where it cools off towards the edge of the bed, and that's where we see a lot of people getting curling issues. So I've been looking at a better bed insulation means, and through one of my friends at Down CNC here in Okotoks, who does a lot of CNC work, he is my go-to guy, just so you know, for any kind of CNC work on my printers. He told me about aerogel. Now, if you haven't heard about aerogel, this is one company in Canada here called Rova Flex. The brand name's Rova Flex. And if we crack one of these open, I believe this one is a 1 millimeter sheet, 1 millimeter thick, and it's the measurement is 250 by 250 millimeters. So it doesn't quite cover the whole bed of a CR-10S, but it gets it pretty close. Now, if we pull this stuff out here and take a look at the actual sheet, we got a sticky side and we got what kind of looks a bit like a bubbly side. I don't know if that's going to come through on the camera here. But what this is it's a material that was developed kind of with NASA, actually, and it was designed for space insulation. And what it is it's almost 95% air in that 1 millimeter. And the thing is, the thermal properties of this, it acts, I'd have to pull up the exact numbers, but it is almost perfect insulation in many circumstances. Now, most of the time you get it in 3 millimeter thick, 6 millimeter thick. There's one called Space Loft. I've been trying to get it in from the US, but I won't lie to you guys, that's not very cheap at all. I think it was about $70 for a 50 mil by 50 mil sheet. But those ones promise such a high, such a low thermal conductivity factor that you can hold a blowtorch on one side of it and have your hand on the other side, and it might get a little warm, but you'll never burn yourself. And it is truly fascinating. I wish I had saved the photos on my computer. Maybe I do have one here. But the thermal conductivity of it is so low that all it's going to do is reflect heat upwards. Now, this sheet here on Amazon Canada, this 25 by 25, $13, okay? $13 Canadian, so we're talking $10 US. I peeled off the old one, which was a sticky mess, I won't lie to you guys, and the foam wouldn't come off nicely and all that, but I eventually got it close enough that I was able just to go and stick this one over top of the remainders, if you will. And I've found my CR-10 has heated up at least 40% faster on that bed just by applying this one sheet. No electrical changes, no nothing. But it goes and basically insulates it. Now, I really want to show you guys this photo because this is so cool. I sent it to a friend at the time. Let's see if I can find it here for you. Okay, perfect. So I got two photos now. Hopefully these do come through for us. They are low res because, I'm sorry, I can't afford a proper thermal camera, if you will. Thermal cameras are very expensive here in Canada. Let's see if we can pull this up here. Image 2. I'm running OBS for you, those that don't know, and so I don't really have it set up to do this stuff often, so I have to do everything manually. And as we improvise and do this show live, that's what you get to see. So, what we've got here Let's change that image out to the other one first. Okay, so here is a photo from my thermal camera of heating the bed up to 60 degrees. So what you can see here is, if you look at these cameras rely on infrared light, and then without getting into the boring details, the camera itself, basically when things emit heat, they generally put out infrared light. And what these cameras do is they take all that data of the infrared light and then they color grade it based off a scale, and that's what you see on the right. And because it's dynamic, it doesn't always mean that this yellow here, if you will be the same temperature every time. So what we're seeing here is a little bit of light reflectiveness, but otherwise you can actually see the dots around the four corners of the bed where the bed mounts are, because they are slightly cooler, and you can see the overall sheet itself actually maintained quite a warm factor across the bed. Now, this doesn't really explain much about, it does show that it does spread the heat a lot more evenly across this plate, which is a good thing. However, if we go and swap this image out for another one I took, right here, have a look at that. So that's my hand. This is with the bed flipped upside down. Now what you got to understand is, even though it looks like that pad is very, very hot, that's because light still travels through this. So what we're actually seeing is the heat underneath it. And what we're seeing here is my hand, I'm resting it on this sheet while it's, I think it heated up to 70 degrees or something in this case. And it felt like it was maybe 28 to 30 Celsius on there. Unfortunately, I don't have the last photo that I thought was... I really wish I had kept that photo on here, but when I lift my hand off, you can actually see the traces of where I had my hand on the bed, because we're seeing a lower thermal light response from the top of the pad. This stuff... This is huge stuff, guys. And I've only seen a couple people try it on 3D printers, but nothing in the community yet. That was with this sheet that's only 1 millimeter thick. It's already about a third of the size of the stock insulation that comes with your printers. And we're going to be playing a lot more with this. Now, Cortex CC doesn't get stuck to the top or bottom of the bed. This, you put it on the bottom of the bed. Now, I won't lie to you guys, RevoFlex, this brand, they claim on the, where is it here? They claim that it's an insulation tape, if you see on there, right? And it uses Arova silica aerogel powder, blah, 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 blah. You can cut it through, oh, here's the thermal properties we were talking about there. Hang on there. So, operating temperature. Now, I was going to try this on a hot end, but you can see it only works up to 120 degrees. So that's a bit of a no-go there. But look at the thermal conductivity factor, all right? 0.036 to 0.04 watts per millikelvin, I believe that the conversion is there. Absorption rate is extremely low. Acid resistance, stored in a cool, dry place, blah, blah, blah. It's got all the details all there, semi-permanent. I just stuck this on the bed and it just worked. Now, even though it's got this plastic that you peel off, they say it's adhesive. This new batch of RevoFlex is not very adhesive, so you may have to apply your own adhesion tape. However, even if there's a little bit of an air gap in there, it's going to stick right to that bed. And it's going to go and help insulate it far better than the stock insulation in there. So it's cheap enough for you to kind of look into. I'm just seeing here, Tom Taylor says, I have probably a quarter-inch silicone pad on my heat bed. Now, I have done a few beds that are silicone. They do great for spreading heat. They're not great for insulating. So, especially if you got a silicone pad, you should really look into one of these, because it may not speed up the heating as much, but it's definitely going to reduce your power. Because again, right now with a silicone pad, you're radiating in two directions. And that bottom of the bed, it's just going to push heat downwards, which is going to go into your room. It's going to warm up the room. It's just wasted energy. So what we want to do is we want to go and insulate the bottom of the bed so that all of the power being applied through that MOSFET and through those traces on that big thermal, on that big bed, you want it to go upwards and be used purely for bed adhesion, because that's why we do this. What size would I need for the Sidewinder X1? I believe the X1 is a 300 mil by 300 mil bed. I won't lie to you guys. In Canada, this stuff is hard to get a hold of, okay? In the US, it's far easier to get a hold of because the distributor of one of the brands, which, if I look up Aerogel, aerogel.com, they do sell to the public. It's just a little expensive to ship to Canada, and they've got all these different ones. Let me see if I can pull this screen up for you guys here. Let's pull her up over. This is the problem, is I got a bunch of scenes and I haven't built anything yet. It's been one of those weeks. Alright, where is our display capture? Display capture, not that one, but that one. Okay, so this company, Aspen Aerogels, has a bunch of different ones, for instance. Space Loft is the one I've heard a lot about, but I haven't been able to get it. These guys are out of Massachusetts, but there's a couple different companies selling it, and I think I went for Buy Aerogel online. But you'll see if you go into NASA's website, this covers the whole science behind it. It's really cool to actually read through and understand it, and it's a very lightweight material. It's got the texture of styrofoam, but the weight, it's lighter than a sheet of paper, to give you an idea. Aerogel Buy. This is my great keywords. Buyaerogel.com. Yeah, so these guys here, they got like silica blocks for education and all that. Hopefully this eventually sneaks through. There we go. And what they've got is, if you get into the blankets, for instance, and we go into like the cryogel, it's a lot cheaper in the US than it is in Canada. And this is what I'm trying to get at, is that you can buy them straight from these guys. So a 5mm sheet that is 12 inch by 12 inch, which converts to 30 centimeter by 30 centimeter, $30. Now you'll see this stuff, it's definitely a lot more, it's got a lot more kind of fiberglass sensation to it. All I would say is read the data sheets, be smart about this. So you can see right down here, the thermal conductivity of this one, it basically can only conduct heat through it at a quarter of the rate of the sheets that I bought here. So you're actually getting 4 times more efficiency for only 3 times the cost. So it's actually a better value. Now the downside is, when I looked to ordering this, I think the shipping was like 50 or 60 bucks to Canada. So I haven't got one of these in yet, and they do have longer sheets. So my intention in the long run is to buy something bigger, like say a 12 by 24 or 12 by 48, and cut it up for several printers. Now, you just have to understand with a lot of these, like these ones, for instance, it's lighter than Space Loft, but it is dustier. And that's the one side that I haven't investigated. That's why I haven't told people, go out and buy this right away. The reason I bought this other one that we looked at here, the Revo, was purely because it was available on Amazon Canada, and it's cheap. They have some paint-on ones too, a liquid, but I haven't gotten that yet either. Basically, it's air insulation, and it's so efficient, I think it's going to be the next upcoming thing. So Tom, you were saying the silicone dense... Okay, so yeah, it varies brand to brand. The silicone beds I've looked into are basically just using the silicone as a means of dispersing the heat, but there's no insulation layer on the bottom. If you ever look into a silicone bed, it's actually quite cool learning about the technology. It's just a big old mesh of wires that sit in between 2 silicone membranes. It's nothing complex, but the reason I don't advise people to change them all out is because you're introducing AC power into your 3D printer, and if people get lazy with their contacts or they screw down something too tight, you can get quite a good jolt from AC. So yeah, the silicone beds are great, don't get me wrong. However, if you got a regular 3D printer bed, it's just as easy as sticking this on the bottom. And as I showed in that previous photo here, if I pull it up again, where is it hiding? There it's hiding. If we look at this photo again here, you can see the pad that I was just holding there is a 250mm by 250mm, and you'll see it doesn't cover the whole bed. In fact, it just goes up right up to the risers for your bed. And you'll actually see my silicone spacers there that I showed in a previous live stream. They don't transmit really any heat through that. I actually had to cut out just a little bit of the corners for the screws to line up. But then once I stuck that on there, you only have 100 millimeters, 25 millimeters on every side of space left where it's uninsulated. Now, if I bought another one of these sheets and cut up in strips and pasted around the outside, even better. The only thing with putting one of these down is make sure you can access the thermistor afterwards, because you don't want to have to rip this out and cut it up. So in my case, what I ended up doing was I just cut a little bit of an access hole in the center just so I could grab that thermistor if need be, and then I just put the sticker right back down, so you can peel it off, put it back down. But yeah, this is getting into some pretty cool technology, honestly, guys. I'm really excited for the thermal insulation, because when you put this on a bed, because all that heat is going just to your part, basically printing on the bed, number one, it's going to use less power. Now, we haven't actually measured the power difference, but it is definitely going to use less power. Number two, it's not going to radiate unnecessary heat in that room. And if you guys know printer rooms, they get warm. This room right now is about, let's see if I guess I got two printers going right now. It's about 25, 26 Celsius in here. Got the windows open. Actually, I had to fire up the AC yesterday. Audio's out of sync. That is entirely possible. Truth be told, I'm running a new capture card here too. I didn't have time to tune in the audio delay. Let me see if I can do that. Filters, audio properties, sync offset. There we go. Let's try 150 milliseconds. Let's see. Is that better for you guys? Let me know. Thumbs up, thumbs down. I will not change it until I get feedback from you. Wow, we are already 26 minutes in. This is my caffeinated Sunday, guys. What's on your printers this week? Oh, hey, that fixed it. I just punched in 150 milliseconds audio delay. Guess I got a good guess. So I'd like to know from you guys, what are you guys working on this week? What's your project? What's your Bane, not to be confused with Amin Baines here of Matter 3D. If you didn't meet him last week here, Amin is one of the owners of Matter 3D, located in Victoria, BC. And we've had some great filament coming in from him lately. I'm super excited to hopefully share with you guys what's coming in the future there. But yeah, the filament has been printing wonderfully on my machines. The only ones that were problematic, turns out it was the machine. Who would have guessed? So yeah, while you're here, go ahead and hit that like button if you like what's happening today. Hit that thumbs down if you don't, and then Richard will be sure to kick my butt later. And subscribe to us if you haven't already. We do this live stream every Sunday at 12 p.m. Mountain Time, which again seems to be changing because of these time zone changes. But this time, every week, where we answer your questions, you can send your questions to questions@thefirstlayer.com, and we will go and address them on the following show there. And then if you need any additional follow-ups, we will try to follow up after the show. Marcel, I'm here in Vancouver. Oh, lucky guy, lucky guy. I grew up in Victoria, for those of you who didn't know, so it's the island is always calling, and the mainland, the Lower Peninsula, you know, it's a gorgeous area there. Only downside is if I moved there, I would be having a heck of a time with 3D printing because of the higher ambient humidity, or relative humidity, if you will. Let's see here. After a couple months of great prints, the last few prints, it's doing a layer shift every so often randomly. My belt is tightened and seems fine. So, layer shifts can happen for various reasons. Usually, it's a result of the printer trying to move too quick, whether it's a mechanical drag or it's that you bumped up your speeds a little too much. So usually dealing with that, the first thing I would say is, have you noticed any ringing on your prints when changing directions? Now, if you're seeing ringing, unfortunately, I really don't have a good example here to show of ringing, but ringing occurs when it tries to change directions too rapidly, and so there's actually a little bit of vibration. The best example is, let's say you're trying to do a burnout around a corner in a vehicle, and you punch the gas and you go around that corner hard. Your back end may sway a little bit after that, and that's essentially what you're seeing with your nozzle, is the sway marks of changing directions. So the answer for that is usually to slow down your acceleration and drop your jerk settings. Most printers out of the box are fairly good, but I've tended to notice that they set the jerk too high. So take a look at that. Richard and I use, usually at the highest end, 8 on the X and Y, sometimes down to 5 if it's really problematic. And you're saying you're running at 40 to 50 millimeters per second. That's fairly slow, so you shouldn't be having that. So if you're having big layer shifts, and it's particularly on a single axis, it may be possible that your nozzle is dragging around that layer point, and because the motor currents are dialed in such a way that it doesn't overheat the motor, at a certain point, it just can't overcome that drag, if you will, and so it pops. Now, we've talked a little bit about these little stepper motors in the past, but basically, out of all these 6 wires you got here, unfortunately it's a little bright, out of all those 6 wires, you only use 4 of them. And what that corresponds to is electrical coils. Do I have a disassembled motor here? Because yeah, actually I do. I was tearing apart motors yesterday, so we're going to go ahead and pop out a motor core. So, your rod here is just this spinny little coil. It sits on 2 bearings inside a housing. And you can see all those little teeth there that sit in the center. Now, if we go and look at the inside of the motor, now what you've got is all these different coil setups to jitter through those little microsteps. And all it does, if you notice, there's actually only 4 major leads coming off the top here. And what it does is it pulses. It does a pulse and then moves it in a full step would be 1.8 degrees for most motors. Now, apart from knowing which coil is active, it doesn't know if you're at 1.8 degrees, if you're at 3.6 degrees, or any multiple of that. And so that's why we always say steppers are dumb. That's why we need end stops generally. The Trinamics have some intelligence to detect the load on a coil to say, hey, maybe I whacked into something, but otherwise it has no idea where it is. And that's where wherever I just put it here, that's where the closed loop steppers come into play. And I'm going to do a video on that shortly there, but basically they're dumb devices. So if it skips a layer, it simply does not know. And in this case, Marcel, what I would look at is what environment variables have changed if nothing has changed on the printer. Has the room become a little bit warmer? Has the humidity changed? Are you using any new filament by chance, like a new brand or a new batch of filament? Have you changed any slicer settings? There's a whole plethora of factors that can contribute to this. And, if you're noticing it's happening at the same spot, it might be some binding on your Z-rod, and it might be a good time to do that annual maintenance of just lubricating your rods, giving them a wipe down to make sure there's no gunk built up that caught onto grease over time. Just make sure the machine can move fairly freely. I wouldn't say it's so much to touch it for the Z, but for the X and Y, just disable your steppers and move them around. Make sure there's no weird tension. Make sure it moves smoothly across your axis and doesn't have points where there's more pressure versus others. Otherwise, it could be a bed leveling issue too. So just we'll take a look through it. Maybe if you get a chance, if you can send us a photo at questions@thefirstlayer.com. With that, I would love to take a look and see if there's something we can point out on that. Using Polymaker Max filament, new filament for me, it's just really happening on the Y-axis. Maybe try bumping up the temperature just a little bit, just to see if the Polymax here, or what was it there, the Polymaker Max, make sure it's just make sure it's melting freely. And you can also, just to make sure there's not extra tension or blobbing buildup, just go lift your nozzle up and extrude 50 millimeters of filament. Make sure it can smoothly extrude it, if you will. Now, we've talked a little bit about drying filament too, but I want to emphasize this is another test you want to do. With any filament, you always want to heat up your nozzle and do a purge of about 50 to 100 millimeters of filament. And the reason is you can actually tell right away if your filament is moisture saturated. In the worst cases, you're going to hear a lot of popping, but generally what you're looking for is you want to see it come out smoothly out of the nozzle. Now, if it's kind of clumping out, or it seems to have little thinner parts more than thick, then yeah, you've probably got some water-saturated filament, and you really need to dry that out. We've talked previously about the Salton dehydrators and various other brands of dehydration. It makes sense to invest in some kind of drying platform just to assist in making sure that filament is prime. And we know with manufacturers, wherever they are, It doesn't, even with the desiccant packs in there, there still can be moisture that comes with an apparent dry reel. And it doesn't always come out as being ultra brittle. It'll sometimes show up as this bubbly nature coming out of the nozzle, as I just explained. So just like when we say do a temperature tower when you get a new roll of filament, just do a little extrusion just to make sure. It's going to cost you nothing, and it's going to save you a lot of wastage. Dominic Versetto is asking, I have an Ender 5 with a Titan extruder. Would it be possible to print Ninja Flex through the Bowden tube, or should I wait until I can afford direct drive? So, yes, with a caveat. Flexibles are... they're interesting. The flexible material, because at no state does it become firm, you basically are restricted in how you can push it through a nozzle. So the reason we push for direct drive is because with a direct drive setup, the flexibility, if you will, because it's being pulled all the way to the extruder, you don't have to worry about it wiggling in the tube. Once you get to the pushing part, you need it to come out of your nozzle. You need to go down straight, and you need to go through there. So what we have to look at is, what prevents flexing? Now, all I've got here right now is welding rods from my Tuesday tip for those members who got to see that this week. Welding rods are kind of flexible, not as flexible as a PLA or as a Ninja Flex. But, when I'm pushing on the back of this, it's pretty much guaranteed it's not going to bow really heavily unless I have a jam on the other side. When you get into flexibles, it doesn't take much resistance for it to bow. And even though the end is liquid, if you will, by the time you get to there, you need something constantly pushing it along. And this is where we get into the headaches with a Bowden setup for this. So if you set your Bowden tube way back, and I don't have any Bowden tube here right now, number one, the first thing it's going to do when it encounters tension is it's going to bend inside your little diameter there. So that's why we always say you really do need, what's that brand? It's slipping my head right now, the really good Bowden tubes. You guys can tell me in the chat and make fun of me. But you need a good quality Bowden tube that has a very small inner tolerance, so there's nowhere to flex. Then, if you've got all that, now you need to make sure that it's not going to ever bow outwards in the extruder assembly. Now, if you've seen a photo of an extruder assembly, you might have a pretty good path on the sides, to keep it going straight. But you got nothing on the top and bottom, and that's where we see the most failures with TPU. Capricorn tubing, thank you, everybody. Can you tell I haven't ordered any in a while? It's good stuff. But basically, if you have nothing to restrict your filament from moving up and down inside your extruder assembly, there's a really good chance at some point it's going to bend on itself from a point of resistance, and then it's just going to twirl outwards, and it creates an absolutely gorgeous failure. But pulling that back through the extruder when it fails is such a nuisance, rewinding your reel, all that. So simply put, you're going to have a better time with direct drive. It doesn't mean you can't do it, but I would say print it very slowly with low accelerations if you are trying to do it through Bowden. And be prepared for it to fail, because it doesn't always work out. In fact, even with direct drive, I've had some headaches. I don't print it too often, but hopefully that gives you a rough idea of where to go with that. All right, Greg's Vintage Workshop. Doozy of a question, so let's see if we can work through this here. Sorry that we missed your email, apparently. I will check into that. Oh, okay. That's why it fell apart. On an 83-hour T800... Oh, you're doing that one? I know a couple people doing that one. Randomly, a layer shows up looking squished around the entire circumference of the entire head. It does it randomly. It might go several centimeters and be perfect, then the squish occurs and might be fine for another centimeter and happen again. Okay, so this is probably a result of your Z rods, and it could be a result of a pinch point, if you will, but it does seem to be kind of random. My question is, are you doing a lot of Z hops when you're doing your print? So what would that look like? Now, actually, this cube does actually kind of show a little bit of this. You can see there's a couple points. It doesn't so much double, but you can definitely see that line around the Y where it did have a little bit of a crunch there. And otherwise, the rest of it looks smooth. This is one of the calibration items we talk about often, is making sure your Z rod is straight and making sure that the coupler, if you will, is turned back just slightly. So when you take a look at your Z rods, the first thing I would say is move it about 100 millimeters up using the menu, and then go look behind the printer. Now, if you're seeing that rod go like this, then it means you have a Z rod misalignment and you need to straighten it. If it's fairly straight, then it might mean that the bolts that hold the coupler onto that rod are just a little too tight. Now, I'm going to emphasize this. In a perfect world, you would want to tighten those bolts down all the way, because it's never going to shift back and forth. In reality, we're never going to be able to perfectly eliminate that, even with printed parts. There's manufacturer deviances on the Z rods and all that stuff. So when you see a squished layer, it might be a result that it tried to do that micro step up, but it just didn't have enough power to overcome that particular little blip. And given that it's a Rock 3 Pro, I don't think you're going to have to make any changes to your motor current. It just sounds like there's an abnormality on that. So first thing I would say, clean those rods. Whatever grease is on there, get a paper towel, or preferably something like a Kim wipe that doesn't generate any kind of flakes, or give that rod a nice wipe down. And get yourself some like sewing machine oil and get some of that in there, because that stuff doesn't bind up. Don't use WD-40 or anything. Make sure it's nice and clean, and make sure it can cycle up and down that Z rod nice and smooth. If that's going smoothly, then as we've talked before about that little coupler that screws into your gantry, you do want to bump that back a little quarter turn just to give a little bit of playroom in there. And you'll know if it works right away, because either your print's going to look great or it's going to look beyond terrible. So the whole goal is to try and keep it down on your diagnostic steps, right? So I would say look at that Z rod, and then if that's all nice and combined, then pop us another email, and maybe with your printer settings, I just want to have a look and see if it's moving a little too quick for that gantry. But generally, it's usually pretty good at holding its position. Pure Life RC, yeah, 3-in-1 machine oil works very well. I've heard that stuff is great. I literally cannot get it in Canada. We've tried. Same with the other 3-in-1 products like the PFTE spray for your resin printer. I just have not been able to acquire it here in Canada. So great tip for our American friends. Yes, 3-in-1 machine oil is great. I just picked up sewing oil from Walmart, and since Walmart's pretty global, you can usually get most things at every location. So any kind of oil, the main thing is don't use a grease, don't use something that would bind up. Really, Canadian Tire sells it. Okay, so you guys, if you have never been into a Canadian Tire, they've got some really cool stuff for your printers lately. And not so much direct products, but things you can use on your printers. Any kind of L brackets, if you want to reinforce your frame, I've been buying them from Canadian Tire because they had L brackets in. They've got a lot of metric bolts in there. Canadian Tire has it. I bought these welding rods there for a project. Any of my painting supplies for my printer, because it's like right behind the house. It's a surprisingly good store. Not to give out the stereotypes there of Canadian men and women wandering around the aisles and buying everything there. It's a pretty universal store these days. So yeah, if you're looking for some supplies for your printer, maybe pop in there. You might find something cool. Hopefully, yeah, Greg, hopefully that got you in the right direction there. As I said, send us another email and let us know the results of that, because I do want to get that working nice for you. Pab TV, how can you tell if a CR-10S box fans fail? Well, what a question, because that was something that happened with that there machine. So, first things first, you're going to get layer skipping because the motors are going to overheat. So, if we take a look at your printer board here that we got, really there's only a few things in here that can generate a large amount of heat, namely your steppers at the top, hopefully not your microcontroller, but these MOSFETs down here. Now between these and this is where most of your heat's going to exist. Now these, you don't want these to overheat, because that's when you're going to have to, number one, replace this entire board, but number two, your printer may thermal run away and do a bunch of headaches. The steppers themselves, as I learned this week, because I've been doing a couple open air tests with Trinamics, when they overheat, they shut down, and then they kick back in. And I wish I had shot video of this, but what was happening on this CR-10 behind me was that the fan had failed inside the case, and I basically could tell because when I touched the top of the box, it was noticeably warmer than the rest of the room. You know, a couple degrees is fine, but when you start feeling like it's 35, 40 degrees, you know it's way too warm. Now, what was happening was I started a print, and the layers were all jittery and weird. Actually, maybe I do have a piece still hidden underneath the machine. Let's see if I can reach underneath here and squeeze something out while she's printing. Maybe not. Maybe. All right, hashtag pray for Brian here. Try not to cancel this print. This is what happens when you grab parts. Just shimmy them off the bed and then try to start another print. You know what? I'm going to do a bad boy. I'm going to lift up the printer and then drop it. Oh, no, it's gone. Okay, another piece. Let's pull one of these out. So these ones didn't turn out too bad, but describing Greg's issue, actually, this piece right here. Let's see if I can get some shadow on that for you. Is that coming through for you guys there? You can see that band in the middle. That was it trying to. Oops, sorry, there we go. That was it trying to raise when it couldn't, and it was a terrible sound. Okay, the motor itself actually went clunk and then kicked back in. I thought there was something wrong with it. So it wasn't until I dug into it that I found the fan right in front of the motherboard was completely seized. And luckily, I actually had just purchased some 10-volt fans from DigiKey, and I was able to retrofit in a 60 mil by 60 mil fan, which it's bigger and therefore it's quieter. And that's, you know, the big thing with fans, right? It was a bigger fan equals same airflow but quieter. And it's been working perfect ever since. Now, if you're ever worried about a fan, if you want to give your fans a good look over, I wish I had kept it. I literally threw it out yesterday because I didn't think I'd need it. But the fans are supposed to be free spinning. And, you know, if we go, let me see if I got a junker fan around here. Actually, I think this one could work. I just pulled it off I just actually upgraded this one machine to a 40 mil fan. But, let's see, do I have my trusty iFixit here? Where is it hiding? Welcome to live programming, guys. Hang on. I will just go and find it. I will be right back. All right, here we are back. Okay, so I didn't find the iFixit kit, but I actually found the fan base here. So, standard in a printer, you might notice we're actually missing the blades here right now, and I'll show you why momentarily. So, behind the sticker here on any fan is usually a little pin followed by a little plastic grommet that holds it in place. Now, if we flip this over, this is what a fan looks like once you've removed that. And what we got here, let's see, there we go. What we've got is a bunch of coils in here, and it basically floats on there and free spins on the bearing. So the plastic clip holds it down because it actually wants to magnetically shoot outwards. It holds it in place there, and then as you energize these coils, it generates a circular motion. That's how a fan works. Usually what I've seen with fans seizing up and failing is a result of drag inside here from general material, whether it's hair, dust, anything. I won't lie, these are a pain in the butt to service, so I only recommend doing this if you have a fan that you just simply can't replace. It's just not worth your time. So what I end up doing is, you know, with this one, I couldn't figure out exactly what had seized it up. It could have been a bad coil. It could have just been some drag in it. Again, it wasn't worth keeping. Now this here is a sleeve bearing fan. And I'm gonna go through some fans a little bit in the future here, but simply put, you want to get either a ball bearing fan or a similar type to ball bearing, similar to Sunon's what do they call here? Vapo barrier something or other. I won't lie to you. I've replaced pretty much every fan in my printers with Sunons. They're great fans, and if you know how to spec one out through DigiKey, you can get some really good fans for about $10 to $15 Canadian and next day shipping. So maybe look into that. I know we kind of went off on a bit of a tangent here about fans, but hopefully that did give you a bit of information on them. The print, Gregson, the printer was brand new when I did that 86-hour print. Probably should have waited. No, you shouldn't have waited. No. I mean, I would say you should have still done your temperature tower. You still should have done a cube just to make sure. Just to make sure everything out of the box works. But go for it. Once you've got that in there, bear in mind the only thing that a test like this does not cover, it doesn't cover when you're trying to print something tall. Right? It doesn't cover Z-rod issues at the very top. And a lot of people, they don't lubricate the whole rod, thinking, I'll just lubricate the first bit and drag it up. No. If you're going to do this, do it right. You know, put some lube all the way on the rod, all the way to the top, and then, as funny as this is sounding, you want to stroke it. You want to go and move your Z up to Z300, Z350, whatever maximum you're comfortable with moving your printer to, and you want to go up and down a couple times just to make sure that the rod is equally lubed and that it can freely move, because sometimes, as I said, on the lower layers everything looks perfect and then your Z rod actually starts to wobble as you get close to the top. It's a very fine balancing game when it comes to calibrating it in, but once you've done that work, you're going to be good for probably 6 months before you even have to consider checking and seeing if your lubrication needs to be reapplied. Peter Reynolds saying, is Tri-Flow a good lubricant for Z-rods? I haven't tried it. Let me take a look into this. Now, truth be told, I really shouldn't speak too much about polymers and chemicals with some of the experts in the room. But what you want to look into, Tri-Flow is just a brand name, right? And when it comes to lubricants, what you actually have to look into is the ingredient set. Right, so for instance, Tri-Flow here, if I pull up Ace Hardware's website, let's see if we can take a look at this here together. So here they've got a general purpose lubricant. Now when I searched up Tri-Flow initially, I had all these, superior sprays, greases, all that. That's why I say don't just say buy Tri-Flow. So this spray, never go for a spray, because usually sprays are, number one, you're never going to get a nice even coating, and number two, it's going to spray everywhere, especially when you're applying to a Z-rod. You want a liquid of some sort. Now, synthetic grease, again, because these motors are very low torque, you don't want to go with something like this, even though it's like PFTE based and all that, because it's just going to create additional drag that your motors aren't calibrated for. There are circumstances where your torque is so high it's not going to matter, and this is going to be more effective in the long run. But since we're not even going to have our components heating up, we want a very viscous liquid that stays cool. So if we take a look at the Tri-Flow liquid here, this PFTE one, it looks like it's just drops. And what you want to look for is make sure there's nothing about it. Now, of course, none of this is going to open up for me today, so sorry about that. But you want it to be a liquid lubricant, and you don't want it to be able to accrue, because what's going to happen then is any dust in your air, if we get into the gross stuff like your skin shedding all the time, all that stuff is floating in the air. And if you have fluids that tend to group this up, you're going to start getting gunk buildups on your rod, and you might actually get worse Z-banding. So if we go to Walmart Canada here, and we search up sewing machine oil, I got this cheap little bottle. This stuff here, like $5 sewing machine oil. This is the stuff I'm using on most of my machines right now, because it's $5. You can find it in their crafting aisle there, and it's so viscous it almost feels like you're dripping cooking oil on your machine. So it's served me well so far. But the main thing is because this is designed to lubricate metal moving parts, that's what we're dealing with. Is we got a brass coupler and a steel rod basically, and if you don't lubricate it properly, over time that steel will etch away at that brass fitting. It's bound to happen, just like filament going through a brass nozzle. Is anything abrasive, any abrasive connection will go and wear it down over time. So something like this, just putting it in there, you know, you don't have to worry about putting in too much because you'll know you'll have goop everywhere. But you know, it's just something simple. There's no need to reinvent the wheel. But if you do have a supplier with proper lubricants, then yeah. Henry Stoffer, I'm confused. Why am I not on the first layer? Do I have to renew every month? No, that should be automatic with YouTube. Maybe send Richard and I a message after the show, and we'll look into that. We'll take a look into that bug there. Truth be told, I'm not managing much with this membership program. My understanding is that when you hit join, it's going to be repetitive, and unless there's a billing issue or something, just take a look at your YouTube billing, and again, let us know because it should all be there. Now, if for those of you who don't know, here we do have a membership program, and we have various levels of support. Now, if you join at the infill level or higher, we provide an additional video every Tuesday on a quick tip, whether it's on maintaining your machine or getting a better quality print, just something random that we can share with you guys to maybe help make your printing experience a bit easier or even a bit cheaper sometimes there. So if you see that little join button right below the video here, that's what that's for. You know, you get different emojis and stuff too. I personally actually haven't used these yet. So you know, if you want, you can send a Richard, and apparently I look like a girl, but that's okay. Let's see what we got in here. We got some cool different ones. So I'm going to go ahead and send a Richard and a Brian to the chat. And for those members that do have that, you can go ahead and click down on the little smiley in the chat for custom emojis, and you'll see the first layer on a first row. So that's something kind of fun for you guys. Yeah, it's that's the way the cookie crumbles, as they used to say. Isaac here is asking, I've switched to a hardened steel nozzle recently. When it comes to temperature of the nozzle from brass to hardened steel, do I need to change the temp? Lastly, how do I prevent the filament from sticking to it? Great questions, great questions. I personally never looked into the exact thermal conductivity factors between a hardened steel and a brass nozzle. I do know that when it comes to hardened steel, they usually recommend bumping up your temperature by about 5 degrees because it doesn't do that great of a job at thermal conductivity like we spoke a little bit earlier with the insulation. In general, the best thing you can do to maintain the temperature around that hot end is to get a silicone sock for it. And that will provide, number one, insulation from the atmosphere around it. And for most of these printers, I've noticed the cooling part ducts tend to blow a bit on the duct, so it prevents a little bit of that flow in there too. But otherwise, if you have that all set up, I would go ahead and bump the temperature about 5 degrees. And then about preventing filament sticking to it, it's a bit of a tricky, slippery slope on that one. There are what they call pro silicone socks that sometimes cover most of the nozzle right down to the tip. But the fact is, it actually has nothing to do with the material and more to do with the heat. So when you're extruding filament, it's going to go to whatever it desires to go to. If you, in a perfect situation, which most people should have this, when you extrude filament, it should go straight down. But if you have any little burrs on your hot end, which can happen many times, it may curve in a certain direction and wrap up on itself. Now, usually, when I've seen filament curling up and sticking on nozzles, it's actually a result of your layers are a bit too close, or you're over-extruding. So what I want you to look into is, how does your first layer look? We're called the first layer because that's what we focus on. If your first layer, if you're noticing little humps on it, and a good way to do it is just run your finger along the print, preferably clean fingers because we don't want grease in there, but run your finger along that and see if you feel little ridges. If you do, you're pressing that nozzle right up against the bed, and when it's trying to push all that filament through, it's not quite at the point of being unable to meet that extrusion rate, so it's gonna bow up and curl up, and in this case, because most slicers overlap your layers, you're actually going to have it berm up a little bit, if you will. And then if you're coming out on a fresh line, the first thing that happens is your nozzle goes down. Let's use this guy as your nozzle here. So it's going to go down and it's going to try to push some filament outwards. And then the first thing it's going to do is move this way. Now if there's too much filament underneath that compression point, as you move, it's going to curl up on this side. And the first thing it's going to say is, hey, that's a nice hot metal surface. I think I'm going to stick to that. And it sticks on there, and it just accrues. And that's when we get the big blobs that everybody sees online, because the most desirable location for filament to go usually is back to its own material. So once that initial heat combination is gone, now it's got something to bind to on your nozzle. So first things first, dial in that first layer. And if you've never done it, please calibrate your extruder. Not all extruder assemblies are the same, as I found this week when I bought a new extruder assembly for my CR10. I thought for sure it was the same proportional size as a standard CR10 extruder, and therefore would be 93 E-steps. Now, when I went and actually did my calibration test, where you pull out the calipers, you measure out 100 millimeters of filament, and you extrude that, I was actually under extruding by about 30%. But when you have such a big nozzle, it's really hard to tell sometimes. So that's what I ended up doing. Hey, Henry, welcome back to the top layer. Hopefully that is working for you now. Apologies for that headache, but it's good to have you back in here. So yeah, watch for that curling. That's the big caveat to building up on your hot end. Now we did cover various ways to clean that hot end, but if possible, you want to try to just give it a quick inspection between every print, because once it's caked on there, once it's turned black and all that, it is a royal pain to get off. And I've played around with some blowtorches and stuff, and it still does like to cake itself on at that stage. You basically have to incinerate it at that stage, because now the material properties have changed completely, and Amin Baines here will guarantee tell you about that sometime. But yeah, it's you want to make sure that nozzle area is clean, and then your offsets and your flow rates are all set perfectly. And then you shouldn't have to worry about, you'll still get a little bit of buildup on that nozzle, but if you start seeing it creep up and hitting the block, then you know you have some issues. Hopefully, Isaac, that gives you some ideas to try out. So in summary, bump up the temperature 5 degrees for that nozzle, and give that hot end a good clean, and make sure the levels are good. But apparently, I have been rambling for an hour. It's 1 o'clock here, and I won't lie to you guys, the weather is gorgeous here. I want to get outside. I wanted to do some painting yesterday, but the winds were blowing too hard, so I'm going to be doing some more experiments. So yeah, let me know in the chat or in the comments below if you're watching this after the fact what your week project is. For me, it's dialing in my machines again. And you can always send any questions you have on the off days to questions@thefirstlayer.com. We will be dropping a new video next Saturday. We just, Richard was producing this week's one, and due to the weather changes, he was knocked out of commission. So I unfortunately have nothing in the backlog I can give you guys this week, so we're just going to take a hiatus here until Saturday, unless something maybe secretly pops up midweek. We will see. But until then, thank you all for joining us. I want to say thanks to all of our members that were able to make it out today here. It looks like Henry, Peter Ranold, Pure Life RC, hopefully I'm getting everyone, Skip Tarrant. Gotta scroll back through the chat. YouTube is fantastic for that. But thank you everyone for being here and keeping me some company as I did this one solo. And until next time, remember that the first layer is always your foundation to a great print. We'll see you next time.